So it's basically the edge of it.
We want to turn off we're on. What do you want to skip up? Oh, you got to do that. What's that?
Yeah, we do the edge.
It's this year. All right. So we'll start with that. That's last year. This took us until January 15th to get the same amount of snow last year.
We didn't get it until January 15th.
Well,
Yeah, we did read it.
okay. Welcome to Weather Watch today. Chris Martin is meeting across campus, so I'll be leading the discussion. Maybe somewhat abbreviated today, but we'll see how that goes. So in the last week, I was away most of it, so I missed some elements of it, but we did get the snowfall that was expected. And, since, late October, we've actually gone all the way up to about 12.3 inches of snowfall for the year. What we're looking at here is the cumulative snowfall. The blue line here is the 30-year average accumulated snowfall up through from 1981 through 2010. As we said many times when we've shown images like this, sort of the standard way to present climate data, because it's recognized that climate in the long term evolves, is the most recent climate period is taken the decade before, or the 30 years of the decade that we're currently in. And so from 81 to 2010 is the period. The blue line is the accumulated snowfall, starting from July 1st, ending at the end of June. And you can see we're well above our climatology right now. Normally, to get to this point, we have to get to mid-January to get to the totals that we have right now. I think Pete was just mentioning to me that last year it took until mid-December before we got to this total, and last year it took until mid-January, I think, to get to the same amount of snow for the season. So we're certainly running well ahead by any measure, and certainly by this measure is the relevant one, in our snowfall totals.
That's this year.
That's this year.
That's last year.
That's last year.
Up about here.
Yeah.
That was January 15th.
It took till January 15th for us to get to this.
More out over here.
So I'm not even going to try to extrapolate it. That's certainly inappropriate, but we can see how we're doing with our snowfall. So above normal, and we'll see what the sort of extended range looks like. The hint that I'll give you is that it looks we're going to be entering a much drier period. So the amount of precipitation accumulated, at least in the most recent run of the GFS for the next 15 days, is probably less than a quarter of an inch liquid equivalent.
How are we doing on total percent?
Yeah, do we have that on?
That's for the water year starting October 1st. So we're quite a bit above normal.
Yes, water year, we're above normal.
We got to look and see where that came from here. And this is the cumulative precipitation for last year's water year. So we started out above normal already.
And we ended last year well above normal. And I think we are, self statistic, I think 5 standard deviations above normal precipitation.
I was gonna say, you can definitely see that biking along the path on the Nona. There's been minor flooding and like the waves lacking up onto the actual grass.
Yeah.
Yeah,
So this has been a wet period. We had a visitor here just a few weeks ago that was talking to them, and they were saying that down in parts of Kansas and Missouri, this is actually Chris Craven, the former a student that graduated from our program with a master's degree, who's now the morning coordination meteorologist in Topeka.
She might be this.
Or the Sioux.
The Sioux? At Topeka, yeah.
The Sioux at Topeka, the science operations officer in the Weather Service office in Topeka, was mentioning that there's still areas in parts of Missouri and Kansas that are flooded from last spring's and last winter's rainfall. So they're still not having recovered. We're about to enter another wet period over this with some of the snows that we're going to be getting later on this winter into the spring. So it can be worse flooding next season, next spring and summer. So this is not really good for farmers, for anyone that is interested, for agricultural interest that depends on having a relatively dry soil. Not too dry, I don't want a drought, but everything you don't want.
Because the snow is building up too. They can't get out there until the snow is out.
And just harvest anything that was left in the fields.
So I saw yesterday like 50% of the soybean crop is still out. So
That's what we find a market for it as well. So it's a different story. Not weather related. And then temperatures.
Here's the goal.
Yeah, so you can see where we are so far this season with the cold. This, again, the same time period, 1981 through 2010. Maximum temperature, minimum temperature. These vertical bars you see here represent the temperature ranges for given periods of time. And you can see we didn't even reach the normal low temperature for our high temperature just a few days ago. This was updated most recently this morning. I think that might have been, okay, can't see the time on that, but one of the other
Oh, as of
interesting,
November 8th, yeah.
is it right in front of me? Yeah, there it is.
On the top.
Okay, and today is this time yesterday I was in a different time zone. It was over the Atlantic this time yesterday, so I'm a little out of it. But we've been below normal over this time period, and we're gonna see that's gonna persist. We talked about that last week. We saw this large scale flow pattern beginning to evolve with a big ridge over the western part of the United States, eastern Pacific, and a trough that was expected to develop over the central US to the eastern US. That has occurred. When you have these large scale wave features in the atmosphere, we'll look at some global maps, you get a sense of they are generally expected to be stationary, in fact, very slowly evolving, and that's kind of the regime that we're in. We have smaller, short wavelength disturbances that go through that larger scale flow that will keep us, that gives some variations to the weather on a slow time, on a more rapid time scale than the cold that we're in. If we've been in this long regime for cold weather, you can expect over time as it slowly shifts, we'll probably get into a regime where we're going to be above normal for a period, and that's beginning to show up in the medium range forecast. We'll see if that actually verifies. So below normal, clearly, and we'll see that we'll stay below normal going forward. Let's first take a look at the satellite imagery over the US. Look at visible first. Across portions of southern Texas, we'll see there's some showers, precipitation there. Off the east coast of the United States, you can see from some of these bays with the cold air coming offshore, still very warm Atlantic off the east coast. And you get these cumulus cloud fields, and I guess they get organized. Maybe Greg, you might want to say a word about this. Like for Delaware Bay here, you can see this much deeper line of convection here. I don't know if it's just because the air has been over much lower.
Can I get a closer up view of that?
Okay, can we get a closer up view of the east coast?
View up the east coast, please.
Visible.
Visible, please.
Color.
Can I get the colors on it? Yeah, there you go.
So here it's Chesapeake Bay or Delaware Bay. This is Long Island Sound here, but I was just curious by why we see these slightly more enhanced. Is it because it's been over slightly warmer water,
Well,
deeper area for a longer
I'll
time?
point out, this speaks to a paper I published back in '05, the lake effect storms.
Uh-huh.
The shoreline geometry really creates the situation that determines what rolls develop in the boundary layer. So what you see these very strong rolls coming off of the New York City area,
Mhm.
coming off of the Chesapeake Bay there,
Right.
and coming, what's the one in southern Jersey there by Delaware?
Delaware Bay, yeah.
Yeah, Delaware Bay. You see those, they got very strong bands there. The reason the strong bands are there, in the bay, you get convergence in the bay from a land breeze inside the bay, which starts the air up. So by the time the air from those bays moves out over waters, what kind of theoretical circulation should develop, you find that they possibly should even be cellular. But because of these bay geometries, they establish a circulation, and that supersedes this effect. So this is where I have a lot of beef with large eddy simulators. People who try to understand the boundary layer with large eddy simulation tend to use periodic boundary conditions,
Right.
and they don't take this into account. But real large eddies, real boundary layer flows are determined by the topography, the coastline geometries, and things like that.
Okay.
Another thing to point out here is you'll see there's gravity waves perpendicular to the rolls, kind of
But these
right in there. Yeah. This is quite typical. Those gravity waves are resonant gravity waves that occur because the flow over the top of the rolls is undulating up and down with the depth of the layer, and it resonates with the vertical propagation in the deep troposphere. So those are one kind of linear type structure that forms. The other structure is perpendicular to that. Those are the boundary layer rolls from Raleigh-Bernard to Convection.
Right.
So it's interesting to see two types of linear structures perpendicular to each other. And this is very spectacular here, maybe not um, uh, completely usual. You don't see them this clearly normally.
Also,
They're maybe not um, uh, completely usual. You don't see them this clearly normally.
also it's with this, relatively higher resolution satellite data that we're getting, we can better see this. We might not have seen this just a decade ago with, 8-kilometer resolution where we were going down to, what's the resolution of those goes?
This particular image, I think, is 1 kilometer resolution. The middle actually comes in, and the red visible comes in at a 0.5 kilometer.
Okay, so this is really,
But that's like at nadir, it's less than that as you get farther away from the center.
okay.
I could also point out, notice the rolls downstream of Lake Erie and Lake Ontario over Pennsylvania and New York. See those rolls there? Those are actually not rolls, those are streamers, if I'm right, that are formed by the boundary layer rolls over the lake,
Right.
from lake effects. And structures moving over the land are actually plumes of something that was created over the lake.
So they're kind of attached to the boundary layer here. They
Right.
extend upward and then they just sort of die off because there's something.
They die up, they stop rolling, and they leave a cloud up there, and then you get a streamer. It moves, it can move for hundreds or thousands of kilometers from the lake.
And depending on the lake temperature difference and the air, you see the vestiges, maybe some of this old lake effect snow, or so some people call it fake effect snow, but we can go to that discussion later. Again,
Too old. We had some data issues.
could you keep that for just a second? Yeah, because we're going to look at the record of things we want to look back at next, or during the discussion. One, if we go back to the image.
You see how there's these linear bands where no snow, snow, no snow, snow?
These could be old snow areas. No,
They
actually,
were
wouldn't
there
be.
right from the
Right.
start yesterday, so
Okay.
I don't know, and somebody else on Twitter noticed it, pointed them out. And I didn't hear an explanation of why they were like that, why they looked like that.
But the key thing is, when we look at the surface maps, at the influence of this snow cover in this region broadly, temperatures, because what the snow's going to do is going to reflect a lot of the incoming solar radiation back out to space, so it's not going to help warm it up. And so we should be seeing temperatures warmer to the north of this band and the south of this band. If you sort of subtract out the fact that it is colder generally to the north and warmer to the south, it's going to be warmer temperatures on either side of this band relative to what's in the band. So we should see that.
Can I interject? Yeah, there's a couple of coming in from our live feed. Chad Rufflesberger, one of our alumni, he saw earlier this week that GEM hinting at some meso-lows over the Great Lakes for early next week. I was wondering how often models pick those up that far out.
We'll take a look at that. If we can recall that, we'll take a look at the forecasting. It was about 2 or 3 cycles ago, or 2 or 3 days ago, there was this very intense mesoscale cyclone that formed over 3 in the Canadian model. And, is that real? It didn't show up in the other models. But this is a new thing, I think, with increasing resolution model, they can begin to at least simulate very highly structured cyclones.
There's one not really forming, but it's.
The one in the forecast was a little bit later in time. We can take a look at that.
So we'll look into that a little bit. Chris Kucharik also notes that Madison's precip total through November 7th is 42.84 inches, which puts us just outside the top 10 wettest years on record. Then he says other top 10 wettest years, 2018, 2016, 2000. Thanks everybody on the stream.
Yeah, thank you everyone for those comments. So let's look back very briefly at the survey for the IR. I mean the IR and the orbit. Okay. So again, you can see in the visible that snow band that we were talking about just earlier, and then the snow over the Rockies that they've had over the last few weeks. But this broad, you can see just the very edges of it, these clouds streaming northward around this big ridge, and then you can see sort of a more northerly flow at upper levels over the eastern United States. We'll see that's going to be mimicked in the cloud pattern.
Another thing you can see there is
At upper levels over the eastern United States. We'll see that's going to be mimicked in the cloud pattern.
Vegetation, southern Ohio, southern.
Oh, and this
I think we see that green area will progress south. If we
Right.
animate that over the past month or so, we'd see it start
Yeah, that'll be kind of an interesting
Move.
thing.
move toward the south.
I think I've actually got those images. We could do a loop like every 6 hours or something, or same time.
Or maybe every day.
Same time every day. That'd be interesting.
Yeah, because I think, so we should see this, to the extent that these pseudo colors that we have here are going to be based on, living,
Right.
things that are growing, we should see this beginning to contract as leaves fall off the trees and vegetation gets cut off.